do you have on the homework? 109, 110. Yeah. Number 10. The make of each car parked at a shopping mall as a histogram. And then they gave you three different types of cars with etc. as a fourth column. So histograms are made for quantitative, and these happen to be categorical. Make sense? So that would be, number 10 would be actually a really good one to make sure you have on your half sheet for next time. So maybe, actually 9, 10, and 11 are all really good ones to make sure that you have the notes on your sheet, because number 9, do you know why we should not use a dot plot for number 9? Does anybody know? What's that? Yeah, like each of the values are a singleton, so you just have like a single dot across. That's not going to tell you anything. So yeah, number 9, just make sure that if you're going to use a dot plot, that you would have repeated values in order for it to work. Okay. Number 10, we just said that histograms are for quantitative data, and the car makes are categorical. So that's why we should not use a histogram for number 10. Number 11, the scores out of 30 on a geography quiz. Would it be good for a stem plot? What do you think? Yes, yeah, I like that. Yeah. So because everything happened at 20, that would just mean 20, and then you have all your things listed in order, and that's not good. So you want other scores out of the 20 range. You want the 10s, and you want the single digits, and you want the 30s and 40s and 50s in there. So 9, 10, 11. Does that make sense for 9, 10, 11? And again, those would be quality things. 9, 10, 11 on page 110 would be quality things to make sure you have notes on your half sheet for the next time we take a quiz, which will be, I don't know. Haven't thought that far out in advance yet. Sorry. What's today? Oh no. That means I have to look. Okay, hang on. Let's see. 1/6 is today. Oh, Friday. Yeah. That means there's no homework Friday. But then all the football players that are going to Ohio will have to come and make it up. That's okay. We'll do it as a group, and the football team has to do it individually. Deal? Palms, are you guys going?
Yeah, we leave Saturday.
Oh, see, you're set. You're fine. Football players, I'm just kidding. I'll make a version B that's much tougher. All right. I'm just kidding. You know, my sarcasm's getting really bad right now. Sorry. I sleptwalked last night. I'm a big-time sleepwalker. I don't know if you all are.
Did you wake up during it, or like?
Yeah. I woke up in the furnace room in the basement. Just standing there looking at the water heater.
That's terrifying.
I don't know. Something was wrong with the water heater, so in my dream I had to make sure that I was taking care of my stuff.
Is this like a weekly occurrence?
There's no rhyme or reason. There's times that it will be every night, and there's times it'll go for weeks and months. So, I don't know. Yeah, it's kind of weird. Sorry. So, I might be sleepwalking right now. I might not have woken up.
Wake up, Mr. Sir. Wake up.
Whoa, where am I? Okay. My friends, I'm going to be on page 13. Page 13 of the notes. And page 13 is just it's relatively simple. These measures of central tendency, these go along. You've seen mean before. You've seen median before. The mean and median are nicely used to look at what your data is doing. The mean and median will then go and start talking about, they will be used when you're talking about the shape of your data that once you plot it. Tastes like old socks, that coffee. I like it. All right. So the mean. This is the average. Okay. If I were to take in all of your last quiz scores, add them all up, and divide by the number of quiz scores, that would give me the average. Okay. So they will use this sign. This is the Greek letter sigma. And in math, the world of math, it means add up. Well, it means summation, but add up sounds nicer in the world of stirrups lingo. Okay? So the Greek letter sigma, if any of you head off to college or have brothers and sisters in college, they might be a part of a fraternity or sorority that might have the letter sigma in it. So I don't think the Greek letters for the fraternities and sororities have anything to do with the mathematical symbols that we're using. But it might. I don't know. So if I wanted to find out the average of students in this same class between myself and Mr. Anderson, we have 28 in this class. My next period's 27. Mr. Anderson has 20, 19, and 19. Either y'all like me better than Mr. Anderson, or periods 1 or 2 are more conducive for seniors to take. I'd like to think that y'all chose to take first or second period because it was better for your schedule, and you just didn't want to have just me, the Rhinestone Cowboy, be your teacher. If you did, well, I'm not sure how much I could teach. I'm kidding. All right, so if I'm going to do this, first off, how many classes are we talking about? 5. Okay, so we have 5 classes. Somebody with your phone, would you please add this up for me? What does the numerator give me? Now it becomes crickets like a phone. What phone? I don't have a phone.
113.
113? And will you go 113 divided by 5 for me, please?
22.6.
So the average or the mean of the stat analysis classes is 22.6 students per class. Hey, let me ask you this. You know that 28 and 27 are my numbers, yes? Does my 28 and 27 increase the mean or decrease the mean? Because of my 28 and 27, does the mean become a larger number because of my 28 and 27, or does it become a smaller number because of my 28 and 27? And compared to 20 and 19 and 19? I make it bigger. I brought the average up. Okay. So, a lot of times, let's see. A lot of times we will call mean X bar. It's an X with a bar on top of it. That's why we say X bar. So the mean is also referred to as the expected value. So the mean can also be referred to as the expected value. And a lot of times when we're furthering ourselves in the class, we are looking at the expected value being the mean, and we are testing based on that. Testing our data to see if we should accept or fail to reject. And I kid you not, that's the language that's used in math. You can fail to reject your null hypothesis, or you could accept your null hypothesis. And you're like, fail to reject. Any grammar folks in here? Fail to reject. You got like 19 negatives all in a row there. Strip can't count. I'll go with it. All right. So, I'm sorry. I went off on a tangent. So the mean becomes the value you would expect in a typical observation or data set. The concept is equivalent to the best guess. So if you wanted to guess how many points the Los Angeles Lakers would score in the next game, you might calculate their mean of their games played so far and use the value to make your guess. Okay, so the mean is not only the way to measure the central part of your data, but is often not the best way. The mean is highly sensitive to high and low values called outliers. Okay, so let's talk about an outlier. Now, my numbers of my class wasn't different. So let's say 28, 27. 20, 19, and 19. Is that the data I gave? I remember. Yeah. All right. So let's say we offer one more class. So right now we had an average of the green of 22.6. I'm going to call that's of the green data. But let's say a whole bunch of students decide they're dropping AP statistics. They say, hey, Stirrup, we need you to teach an 8th period statistics class, which is this class. Well, here's the kicker, Stirrup. You need to teach it in Schilling Law because you're going to have 131 students. And I'm going to say, I'm busy. Well, though it is kind of cool to have 131 students. Now, let me ask you this. So originally we had 5 different periods of data. Agree? Now there are 6 periods of data that are up there. So let's see. Originally we had 113. Now we're going to add, that's what our green adds up to. Now we're going to add 131, and we're going to divide by 6. What is 113 plus 131? I could do that. 244. What's 244 over 6? 40. Anybody? 42? Someone with your phone? Quit acting like you don't have a phone. 244 divided by 6?
40.6.
40.6. So this is my new average, or my new mean. Okay, so what dramatically changed in this case? Was the adding of one more class, did that change it? Or was the adding a significant larger number of students? Did that change it? What do you think? Yeah, a lot more students jumped in. Okay, now, being that there's 5 periods that the numbers are all in kind of close together, would you feel that it would be right for me to use the average or the mean in this new scenario? No, because there's 5 periods that aren't even close to having 40.6 students in it, right? So that means that the mean or the average, same thing, can get swayed by an outlier. So the 131, I think we can all agree that having 131 students, especially in this classroom, that's a lot of people. Agree? Okay, so just know that the mean, which is the average, which we'll call X bar, can be influenced, okay, to where the average isn't good. So this kind of thing could take place, you know, if you were to ask me as a teacher, what's the average amount of students I personally have in class? My medical class has 89 students in it. So would my medical class influence if you were to come to Chris Stirrup, this guy, and say, what's the average amount of students I have in class? Am I painting a picture that is accurate or not if I include my 89 students in my medical class? No. Okay? Can you see how an average could be used as a bad thing. You know, like let's say 9 News wants to do a story on teachers around the Cherry Creek School District area, and they're going to go say, you know, what's the average amount of kids you have in class? If they came to me, my average in class is going to be a lot higher than most other teachers because I have a huge class. Now, other classes that might also be big, I imagine the band room is relatively large. PE classes are relatively large. Okay, but me as a math teacher and also teaches this medical class, my average is going to be significantly different than the rest of the people in the math department. And it doesn't mean I'm a better teacher. It just means that I happen to have a class that happens to be bigger that is pulling my average to the right. Okay, or my mean to the right. So the mean is influenced by outliers. An outlier can also happen to the left of that data. If they came to me and say, hey, Chris Stirp, we need you to teach an 8th period class, and there's only one student in there, one student is far enough to the left that's going to be an outlier as well. Okay? So I just want you to think about that. So the mean can be influenced. Now, I'm going to take this same data and we're going to talk about something called the median. And the median is the middle of our data. The median is relatively easy to find. So I'm going to highlight this first part here. And I'm going to take that first part and I'm going to put it in order. Okay, so this is my original data in order. So my very middle data on this is my median. Okay, so if you look at my original mean, what's my original mean? 22.6, right? What's my median? 20. Okay, so they're relatively close as far as numbers go. Okay, now if I take and I add one more piece of data to this, I'm going to add my 131. What I would then do in this case, because I have 6 classes, so my median is going to be my 2 middle numbers added together, which is 47. And then I'm going to take the average of those 2 numbers. So 47 divided by 2 is 23.5. So does it appear my median, I agree, is different than my original? My original median was 20. When I added one more piece of data, I take the 2 middle values, add them together, divide by 2, and I get to 23.5. Did that 131, did that actual number influence that median? Or did it just give me an additional number to find the middle of my numbers? Yeah, so what it's basically doing is that 131, I mean, look how much 131 increased my original average from 22.6 to 40.6. That's a pretty big difference, okay? But the median itself, though the median is a little bit larger because you're averaging 20 and 27 together to get 23.5, the median isn't being tugged by an outlier, okay? That's the big thing to realize. So the median could definitely do some things in order to do it. So now, the last thing is median is considered a resistant measure. Usually large and small values do not have a significant effect on the median, which we just showed. Therefore, the median is certainly the preferred measure for central data sets when you have outliers. Okay. Now below on the notes are the directions of how you figure out on your calculator, on the graphing calculator. I need to figure out on Desmos how this works. So I don't know yet. I'm sorry. I failed you all. So let me just take a look on the homework. Yeah, you can do all the homework. Let's just do this. Where are we at here? Page 111, 112. And let's have you do 1 through 15 odd. That's what I will check off for tomorrow. But we will also, during class, finish up the rest of them. But if you have 111, 112 odd done, that'll get you the full points for the homework. Deal?